Okay, so the question asks to evaluate the surface integral where S is the helicoid with the given vector equation. And of course here our F X, Y, Z is just Y, and I could express this as a composite function of RU of V to be able to evaluate the integral. So in other words, I go to my F and I replace X, Y, and Z, if there's any, with their corresponding components in U and V. And in this case, I only have Y, so that means it's just going, and Y is U sine V, so this will just be U sine V. And I need my so the surface integral y ds could be evaluated as f of r u v dotted with ds, and ds is nothing but the magnitude of the cross product of ru crossed with rv, partial derivative of r crossed with partial derivative of v. In other words, those are the tangent vectors to the surface, times the dA. And this is a double integral on region D defined by my bounds, where my bounds, where u goes from 0 to 9 and v goes from 0 to pi. And let's go ahead and figure out partial derivatives. So RU will just be cosine v. So I'm taking the partial derivative of r with respect to u. I hold v constant. So cosine v, sine v 0. And likewise, RV will be minus u sine v, u cosine v, and 1. And now I will take the cross product. I did the detail another place. I won't show the cross product here. I'll just write down the answer. If you're interested, you can watch other videos with on cross products that I have, how to evaluate a cross product. So I have let's see, the answer to the cross product turned out to be sine v minus cosine v and u. And now if I take the magnitude of this cross product, this was just the cross product, there's not the magnitude, it's a vector. And now I could do the magnitude of this cross product. So it'll be sine squared v plus cosine squared v, which is 1, plus u squared. So this gets me 1 plus u squared. And now I can go ahead and plug into the integral. So bring this down a bit. We have y, which is u sine v. Then the cross product, which is root 1 plus u squared. It's better to start this with du and make the substitution of 1 plus u squared being w. Then you would get u du to be dw over 2. And then evaluate this from 0 to 5. And then go back and take that answer and integrate it with respect to v from 0 to pi, like our bounds suggest. I won't worry about the details of this integral here. They're fairly elementary. Calculus 1 use substitution. You can review my other videos on that if you're interested. I'll just write down the answer. The answer comes out to be 2 over 3 times 26 root 26 minus 1. By the way, I replaced dA with du times dv because that's just the infinitesimal area along my uv surface. Like saying in Cartesian coordinates, dA is dx dy. Here it's du dv, where it conveniently applies since I already have the bounds on u and v. This concludes this question. Thanks. Please don't forget to like and subscribe.